Hello everyone and welcome to another Math Tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 8 Kinematics in a Straight Line, Long Question Example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A particle moves in a straight line that passes through a fixed point O. Its velocity v meter per second t seconds after leaving O is given by v equals to kt minus 8 minus t square, where k is a constant. The acceleration of the particle when t equals to 5 is negative 4 meter per second square, and the particle is at instantaneous rest at point A and point B on the straight line. So for the question part A, they ask us to find the value of k. For the question part B, find the respective time the particle is at point A and point B and the distance of AB. Okay, for the question part C, sketch the Vt graph of the motion of the particle for 0 less than equals to t less than equals to 6, and hence state the range of values of t when the particle is decelerating. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Okay, for the question part A, we are required to find the value of k. So let us begin our discussion. Okay, so the velocity equation is given that v is equals to kt minus 8 minus t square. Okay, so there is an important information given by the question. It mentioned that the acceleration of the particle when t equals to 5 is negative 4 meter per second square. So let us include this statement into our working here. So when t is equals to 5, okay, when t is equals to 5, so from here your acceleration is equals to negative 4 meter per second square. So from here, the question didn't give us the acceleration equation, but then they gave us the velocity. So from here, how to find the acceleration? It's very simple, guys. You differentiate the velocity, you should get the acceleration equation. So from here, you differentiate this, you should get the acceleration is equals to k minus 2t. So this is your acceleration equation. So since you have the t equals to 5 and the a equals to negative 4 meter per second square, so you substitute this value into this equation. So from here, negative 4 equals to k minus 2 times with 5. Okay, so from here you calculate this, you get negative 4 equals to k minus 10. So you calculate this, you should get your k is equals to 6. So this is your answer for the question part A. So let me underline the solution. Okay, so from here, let us proceed our discussion for the question B part 1, where we need to find the respective time the particle is at point A and point B. Okay, so it mentioned that the particle is at instantaneous rest at point A and point B on the straight line. Okay, so take a look at the keyword here, guys. Okay, it mentioned here instantaneous rest. Okay, so you need to know that when a particle is at instantaneous rest, your velocity will be equals to 0 in this case. Okay, so from here, let us write that down in our working. So question B part 1. Okay, let me write the statement. When the particle is at instantaneous rest, Okay, so from here your velocity will be equals to 0. Okay, so we know that the velocity equation is equals to kt minus 8 minus t square, since we already find the value of k where it is equals to 6. So you can just substitute the 6 into this velocity equation. 6t minus 8 minus t square. Okay, so from here 6t minus 8 minus t square, so you should get equals to 0. Okay, so you move everything from the left hand side to the right hand side. So from here you will get t square minus 6t plus 8 equals to 0. Okay, as you can see here we are forming a quadratic equation. So let us perform the factorization for this. So from here you get t minus 2 and t minus 4 equals to 0. So from here you have two possible answer, okay, where you have your t is equals to 2 seconds and t is equals to 4 seconds. Okay, so let me underline the solution for the question B part 1. So from here we know that when your particle travel to point A, your time will be equals to 2 seconds, and when your particle travel to point B, your time will be equals to 4 seconds. Okay, so I hope this explanation is clear to you. So from here let us proceed our discussion for the question B part 2, where we need to find the distance of AB. Okay, so from here to find the distance of AB, the first step what we need to do is we need to find the displacement. Okay, so from here how to find the displacement? So from here what we're going to do is we're going to integrate the velocity, guys. Okay, so that will be our step 1. Okay, so let us begin our working. Okay, so let us integrate the velocity to find the displacement. So from here S is equals to integration of velocity with respect to time. So let me box this. Okay, so from here S is equals to, okay, the integral of the velocity. Okay, in this case the velocity is 6t minus 8 minus t square, okay, with respect to dt. So you perform the integration. So from here you get the displacement S is equals to 3t square minus 8t minus t cube over 3 plus c. Okay, so from here we're going to include an important information, which is it mentioned that a particle moves in a straight line that passes through a fixed point O. So from here, when t is equals to 0, S will be equals to 0. Okay, so from here you substitute in, indirectly you get your C also equals to 0. So therefore your S from here will be equals to, okay, let me just copy paste this, 3t square minus 8t minus t cube over 3. Okay, so this is your step number 1. Okay, for the next step what we need to do is we need to find the displacement when the time is equals to 2 seconds and when the time is equals to 4 seconds respectively, guys. Okay, so from here when time is equals to 2 seconds, okay, so from here S will be equals to 3 times with 2 square minus 8 times with 2 minus 2 cube over 3. So you calculate this, you should get your displacement is equals to negative 6, 2 over 3 meter. Okay, so let us proceed to the t is equals to 4. So when time is equals to 4 seconds, so from here your s is equals to 3 times with 4 square minus 8 times with 4 minus 4 cube over 3. So you perform this calculation. So from here you get your s is equals to negative 5 1 over 3 meter. Okay, so this is your second step, guys. Okay, by calculating the displacement when the time is equals to 2 seconds and time is equals to 4 seconds respectively. So once you find these two displacement, so our final step is we can proceed to find the distance of AB. Okay, so from here to calculate the distance of AB, will be equals to, okay, we're going to apply the formula. So from here the formula is modulus of displacement at the 4th second minus with the displacement at the 2nd second. Okay, so close modulus. So from here equals to negative 5 1 over 3, okay, and then you minus with negative 6 2 over 3, okay, close bracket, and you close the modulus. So from here you calculate this, you should get the distance of AB is equals to 1 over 3 meter. So this is your distance of AB, guys. Let me underline the solution for the question B part 2. Okay, so from here let us proceed our discussion for the question part C. Let us proceed our discussion for the question part C, where we need to sketch the velocity time graph of the motion of the particle for 0 less than equals to t less than equals to 6, and hence state the range of values of t when the particle is decelerating. Okay, so from here what we need to do is we need to come up with a table consists of time and velocity, and we need to substitute all the values according to this range into the velocity equation. And once we come up with all the information, and from there we should able to sketch the velocity time graph. So this is the idea of this question part C, guys. Okay, so from here let us begin our discussion. So from here let us write the velocity equation. V is equals to 60 minus 8 minus t square. Okay, by the way, I've already constructed the table for you, so let me paste it over here. Okay, so this is the table of time and velocity respectively. So let us put all the range here, start from 0, followed by 1, 2, 3, 4, 5 and 6. Okay, so from here what we need to do is we need to substitute the value of t into the velocity equation, and we need to include all the values into this table, okay, based on the respective time value, the respective time value, guys. Okay, so from here when t is equals to 0, so from here you get your v is equals to negative 8. When your t is equals to 1, you get your v is equals to negative 3. So you just continue from t is equals to 2, t is equals to 3, t is equals to 4, t is equals to 5, and t is equals to 6. So from here when you substitute this into this velocity equation, so from here you get 0, okay, 1, 0, negative 3, and negative 8. Okay, so this step is very important. So by using this data, we are going to sketch the graph of velocity and time. Okay, so from here, so once we done this, now we can proceed to sketch the velocity time graph. Okay, so from here, so please wait for a moment. Let me perform the sketch now. Okay, so this is how your sketch should looks like of the velocity versus time graph. Okay, so once we done this, the next step what we need to do is we need to state the range of values of t when the particle is decelerating. So from here, as you can see from the graph, the particles start to decelerate after the time has exceed the 3 second. Okay, it start to decelerate from the time equals to 3 until the time is equals to 6. Okay, so until here. Okay, so this is the starting point and this is the ending point. So from here, okay, let me just label this. Okay, so from here, therefore, range for particle decelerating is 3 less than equals to t less than equals to 6. So from here up to here. So this is your answer, guys. Okay, so let me underline the solution for the question part C. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give it a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.